The device that we are studying is a USB Universal Serial Bus, used as a reference of a connection protocol. Its principal functionality is that we can storage and transfer information data between several devices. The device has multiple functionalities because of its benefits. Most common uses are data personal transport, secure storage data, application and software files, etc.
Like in the majority of the electronic devices, the USB has physical and electronic limitations or requirements on the it must work. In general, the conditions that must be taken into consideration for proper functionality are avoiding faults and heats, keeping it in a dry environment in which no humidity can affect it, avoiding the exposing of the unit in magnetic fields, and ward off the extreme heat. Other measures beyond the physical care are removing the device safely by expelling the computer software before ejecting it.
In this case, the device includes two components joined into the same assembly. The first one is a microcomponent called USB Mass Storage Controller, which makes the device accessible to a host system, making possible that the enabling file transfers between the host and the USB device, and also facilitating the data transfer, containing a small amount of chip, ROM and RAM. The second one is the PCB, Printed Circuits Board, which mechanically supports and also electrically connects electronic components and resistors and capacitors, including conductive tracks and pads etched from several sheet layers of copper laminated between sheet layers of a non-conducting substance.
To analyze the components of the USB, first we did a cut in the middle of it with a saw. Having the two pieces, we analyzed the components, which was the USB mass storage controller and the printed circuit board. Then we select one of the two pieces and put it in a container in which we add resin. When the resin was dry, we polished it and took the sample to a microscope, in which we could analyze the materials. The materials we appreciate were copper, silicon, and fiberglass. The copper is a chemical element, soft, malleable, and ductile. The fiberglass is a common type of fiber-reinforced plastic using, and the silicon is a hard and brittle crystalline solid. What are some of the desired material properties of the assembly? Well, for copper, what we want is the conductivity. The conductivity of the copper helps the USB devices to function using the current that is given in the USB ports. This is especially useful for charging other devices of all kinds with a USB cable. For fiberglass, what we want is the lack of conductivity. Fiberglass is the most common material using printed circuit boards as a no conductor. It functions as the base of the PVC, in which the copper is arranged in a path for the conduction. The lack of conductivity of fiberglass lets the copper conduct electric current in a structured and defined track. For silicon, what we want is the duality it has as a semiconductor. Silicon is widely used in the electronics industry for its capability of controlling the electric properties by using doping, which consists of adding impurities to it. Using transistors and integrated circuits, silicon helps our assembly as the USB mass storage controller is made from it.
As mentioned before, copper is very well known as an excellent conductor, also very ductile and malleable, which turns into the favorite for conducting electric and cables and electronic components. Has a good thermal conductivity, very resistant to corrosion and oxidation. Soft, with a 3 Mohs scale, 50 in Vickers, tensile strength of 2010 megapascal, and an elastic limit of 33 megapascals. Its crystalline structure is phase cubic center, while fiberglass is strong tension and compression, but weak and shear. Its electric conductivity is null as thermal conductivity. Also, its hardness varies depending on the glass fiber content, going from 31.5 to 47 in Brinell hardness scale. But due to its characteristic of amorphous solid, fiberglass does not count with a definite crystal structure, while silicon is very hard with a 7 Mohs scale, although very brittle. Silicon has a good thermal conductivity. It's a semiconductor since its capability of controlling its electric properties, making it one of the principal materials of almost any electronic component. It is diamagnetic, which means it is repelled by magnetic fields. Its Young modulus is about 130 to 188 gigapascals and 51 to 80 gigapascal of shear modulus. Its crystalline structure is face-center diamond cubic.